So, welcome here on ChaosWest stage on the very first talk of the morning at 11. And I am very happy to introduce to you Lars Rönnelt. He was previously at NIR specialist Quantco and is now working for the health think tank HIA of the German Ministry of Health, and he will give you a talk about a hacker's guide to healthcare and how to improve life with health data. Welcome, Lars.
Thank you very much. Good morning, everybody. Thanks for making it out so early. It's my first Congress, and I'm a little overwhelmed with all the things that are happening, especially at night. So I really appreciate you all being here so early. My name is Lars. I used to be a data scientist. I'm a data scientist by training. Now I switched to bureaucracy, to policy, doing a policy stint. My life kind of looks like this right now. I work in the Federal Ministry of Health in a think tank that is advising policy, sort of bringing in new ideas from the outside and informing the rest of the world about what's going on inside the ministry. And I lead the efforts on artificial intelligence. Today I'm here to talk to you about what to do with healthcare data, because I think there is a lot of talent missing in healthcare that technical people, that hackers have, and I think there's a lot of knowledge missing in the hacker community about what to do with this kind of data. And so I'm trying to address 5 points today and sort of get you acquainted with some of the stuff that is happening. To get you started, is anyone here a doctor? Can you raise your hand? Excellent. They're always the worst listeners. This is a pathologist. What pathologists do is not what you see in crime scenes. What pathologists do typically is look for cancer. So whenever a doctor suspects cancer in a patient, at some point in that journey, they will cut a piece of tissue from the patient. They will send it to a pathologist. The pathologist will harden it with special chemicals, will cut a thin slice of it, and will look at it under a microscope like that one. And they will basically look for cancer cells in that tissue. The whole process seems very scientific. It smells like chemicals. There's microscopes involved. It's fairly opaque. Even the doctor sending in the original tissue doesn't normally quite understand what's happening. And in the end, this pathologist will answer one question: is it cancer? And if yes, how many? And then sort of the doctor that sent the original tissue will work with that information. And as data people, we're pretty familiar with that kind of thing because it's a black box, right? It's input data comes in, then black box processing happens here in the form of this pathologist, and then some output comes back. And so I thought it's pretty natural as data people to ask, hey, what is the accuracy of this black box algorithm in the form of this pathologist? Turns out that's kind of a wild question in healthcare. And I found the results, the answer to the question, fairly surprising. And I want to share it with you. This is a somewhat extreme example. It's very illustrative, but it's in no way out of the ordinary. It's a study done at a German university hospital in Hamburg where they compare the diagnosis that came in from the outside world. Then they had an expert panel of several high-ranking pathologists looking at the same tissue and comparing what did the expert say versus what did the original pathologist say. So we're basically comparing, it's kind of a confusion matrix, if you've heard that term before, where we're comparing the original prediction of a real pathologist with the closest we can get to ground truth, which is sort of a consensus opinion of experts. And the results I thought were relatively shocking. Most medical diagnoses fall on a spectrum from sort of oh good to oh god. With this example, it's about prostate cancer. If it's anything worse than oh good, so if it's sort of on the right of oh good, then your prostate will probably be removed to sort of keep the cancer in check. And in the event that you have a prostate, about half of us do, you kind of want to keep it. So, having your prostate removed is not something that is a very pleasant experience. It's a very not nice surgery to have. It leaves a lot of damage in the body. So sort of having a wrong diagnosis here is important. The first thing you see is that about 2/3 of all diagnoses, the green bars in the middle, are exactly correct. Which means that 1/3 of diagnoses are actually not exactly correct. And you can say, hey, it doesn't really matter, but what does matter is the cases from good upwards, because that's where you either get surgery and not get surgery. And what this data shows is that from these 5,400 patients, out of those that actually by consensus opinion did not have cancer, did not have prostate cancer, or did not have an immediate need to treat, 1/3 of those patients had their prostate removed without the need to do that. So that's a pretty drastic outcome for patients that you would really like to avoid. Now, the question that I ask for myself is, if this were the result of an algorithm, of a machine learning algorithm or some other algorithm, would this be acceptable performance? Maybe not, but for humans is the best we can do. But I think being more transparent about how humans are just humans and maybe not particularly well suited to look at pictures all day, I think would be a good thing to have more clarity in the healthcare system about what diagnoses actually mean. And so this is my starting example. This is called, in the medical community, this is called inter-observer variability. So different observers look at it, and their diagnoses vary depending on who looks at it. Intra-observer variability, so you show the same picture to the same doctor at a different time of the day, also exists and is not much better. The example I showed you is very illustrative, but as I said, this happens in a lot of medical fields, not only for prostate cancer, but for all kinds of cancer, for all kinds of illnesses. And again, it shouldn't be surprising. Doctors are not bad people. Doctors are just humans like us all, and so mistakes happen. And sort of, it's one example of these questions that I think can be answered with data and that currently maybe not explored enough. Another example would be who gets treatment when. So who has access to doctors, how long do they have to wait for appointments, that kind of thing. How unhealthy are waiting rooms? So as people are waiting at their local doctor's office to be seen, often for hours next to many sick people, how unhealthy is that really? Does specialization into more and more specialized doctor's practices actually improve quality of care? Or does it maybe detract from it because people lose oversight? Can we predict the best course of treatment for a given individual to personalize medicine? Or does the probability that a given patient receives hip surgery, so gets a new hip, does that depend on the reimbursement the doctor gets, i.e. the price tag associated with that surgery? These are all questions that you would like to answer with data. And the problem in healthcare is what I call the great irony of healthcare data, which is roughly this. Sort of the more legitimate a use would be, the harder it is for those actors to get access to that data. And the converse holds. As a case in point, in Germany in the year 2020, most patients still do not have some official plan of their medication. What meds are they taking? This is important because you have these cross effects and side effects of different medication. And when they're hospitalized, you want to know what they're taking. And when you prescribe a new piece of medication, you want to compare that to what they're taking already. The really active, really engaged patients in Germany write these little papers by hand where they write down what has been prescribed to them at some point and just carry that piece of paper with them. And then if they go to a hospital and they get out of hospital again, they would have to update that piece of paper. Maybe they do, maybe they don't. It's just not a good system. So as a doctor who is working with patients, every time I see a new patient, I have a really hard time finding out what they're actually taking already and what I can prescribe to them. Then we have this phenomenon of consumer electronics companies increasingly going into the health data space in a very smart way, and I think there's a lot of good things happening here. But basically declaring their healthcare products as lifestyle products, thereby circumventing a lot of those pesky health data privacy problems by saying this is not actually health data, this is lifestyle data, and getting more access. And you can sort of think, why does Apple need to have health data? At the same time, I think a lot of good things are happening here. Patients are becoming more and more empowered to make their own decisions. They're learning more and more, and I think overall it's a good thing. The worrying part about this is that traditional healthcare providers might actually lose track of, or sort of lose the connection to the consumer electronics competition. And then finally, as we heard yesterday, health data does get lost, and it's a terrible thing. This is probably the worst story I've ever heard about. Singapore lost a whole database of HIV, people with HIV, and were extorted for it. And you really don't want that to happen. So what are the learnings for the hacker community, and what are the things that I want to talk about here? First of all, I want to say very clearly, keep hacking. You don't want to lose this data, and I think having people like the CCC community being white hat hackers and making sure that people stay on their toes is very, very important for the safety and security of our healthcare data, because I don't think we will go back to a world where this is all on paper. This will be digitalized, and we will need to make sure that it's safe. The second part I want to talk about is a little more subtle. In data privacy under GDPR, you have this idea of consent. So patients can donate their data. Patients can say, you can use my data to do something. And this conversation currently, especially in Germany, but all over Europe, is very much driven by this idea between narrow consent and broad consent, where narrow consent is this idea that as a data subject, I can say very specifically what can and cannot be done with my data. And so I need to allow every single step of processing my data. Whereas broad consent would say, hey, I can say my data can be used for all kinds of cancer research. And the issue that I see is that the idea of narrow consent is beautiful in theory and is a great legal idea, but in reality leads to situations where, for example, a patient is being asked to sign a data usage form in the waiting room of a hospital by a study nurse. I don't think that's the idea of freedom we had when we first said we want narrow consent, because you have this power dynamic, the patient wants treatment, that is not a free choice what to do with their data. And I think there's a trade-off here between narrow consent and being very specific what you can do with data, and the user experience part of it, of how you can give that consent. And I think being more clear about the chances we have with a broader idea of consent, but having better user experience, is something that would be extremely helpful in health data and in healthcare. Sort of similar to this idea of the cookie banners you get everywhere, where having one switch per tracking cookie, at least for me, doesn't really help me much. I want to say cookies yes, cookies no, on a very simple one-click solution. And then finally, I want to give you some ideas of legitimate uses of things that you can do with healthcare data in maybe kind of an open data style, projects that you can work on to answer, for example, the questions that I started with. So to get you started on something, I thought I would tell you about a few data sets that I think are cool and allow some hacking. The first one are these two. On the left, you see a famous data set for pathology. So what we started with, this is what human tissue, when you sort of cut it and dry it and cut thin slices of it and look at it in a microscope and color it, looks like. Is these pictures on the left. You get them with a diagnosis, and you can train computer vision algorithms to hopefully improve on the quality of diagnosis that we currently have. On the other side, just to show you another example, these are pictures of birthmarks. And the question is there melanoma? So is it skin cancer or not? Both of these data sets are relatively well studied and great places to start if you're into computer vision. Then this is a bit of a German-specific thing because healthcare is organized nationally, and so different countries will have different data sets. But these are two data sets that I think are very interesting and probably underutilized. The one is the so-called DRG browser, where you're actually intended to download software, which then allows you to see certain aggregate statistics about what billing codes are used, what procedures are used. So it tells you a lot about what healthcare is rendered and which numbers in Germany. So the example here is actually birth. And under the billing code for birth, what procedures were done, so what specific procedures were happening. You can download that software online. Turns out that all the data that software displays is just in CSV files in the install directory. You don't even need to install it, but it's very interesting data to just get your fingers dirty on. And the other thing is the so-called Qualitätsberichte, is something that all hospitals have to publish, and somehow I don't think this has gotten much attention in the open data community yet. Tells you a lot of data about what types of procedures, what types of diagnoses hospitals are seeing, and then some. So I don't think this is necessarily super helpful for their quality metrics that they're publishing there, but it tells you a lot about what kind of patients hospitals are seeing. And if you pool this with other data like census data, I think there's a lot of interesting things you can do here. This is another last example to sort of get you thinking a little bit out of the ordinary. On the left, you can see that certain cities have published the availability of their emergency rooms in different hospitals. So basically, for a given hospital in a row, per time of day, you can see how much room they have in their ER for specific diagnoses. So you can say hospital A is getting flooded with gynecology cases, but they're doing okay for bone fractures. And you can do all kinds of things like try and build predictive models on this. Maybe somebody wants to archive the data somewhere. I think there's a lot of interesting things that you could do with this type of data. Of course, originally it's intended to be used for ambulances to see which hospital to drive to. And then finally on the right is a very well-studied example from the US, probably one of the richest data sets that we currently have in healthcare. MIMIC is a data set of patients in a hospital system on the East